Math 1314, Section IC1, Spring 2022, Tyler Junior College, Section 5.4, Linear Equations in Two Variables. Video 1, Linear Equations and Intercepts. Most of the material in this section, and I would say the next section, is fairly straightforward in terms of the types of equations, because we've dealt with some messy equations up to this point, and in terms of the graphs that these equations will invoke. Because all of these graphs are going to be lines, and lines are easy to draw. So let's get started by talking about what exactly I mean by linear equation and how to find intercepts and how we can use that to sketch the line. Well, first off, let's define what I mean by a linear equation, and specifically a linear equation in two variables, because we've seen linear equations before, but they've only had one variable. And when we had those, we solved to figure out what that variable equaled. But a linear equation in two variables is any equation equivalent to ax plus by equals c, where a, b, and c are any real numbers. And what I mean by equivalent to right here is the equation may look like this at the beginning, or it may not, and we can manipulate it by distributing and moving pieces around to make it look like that. And it's not necessary to make it look like this to call it a linear equation. It only has to be capable of being made to look like that to be called a linear equation in two variables. A couple of notes. Note number one, the actual variables themselves, one second, had a typo. I'm sure it's not the only one. The actual variables themselves, x and y, are irrelevant. They can be any two variables. So for example, instead of saying ax plus by equals c, I could have said a w plus b z is equal to c. Whatever these variables are really doesn't matter. X and y are just the default variables when we don't have a specific reason to use a specific letter. For example, if we had an equation relating distance and time, then our variables would probably be d for distance and t for time. But at a generic level, without any contextual meaning, x and y are the default variables that we typically use. And the other note is, it is possible for any of A, B, and C to equal 0. And the reason I bring that up is because if A or B is equal to 0, then that part of the equation tends to vanish. For example, if we had A is equal to 0, then the equation would collapse down to this, and that would technically be a linear equation in two variables. But if y was equal to 0, then this part of the equation would disappear, and we would have ax is equal to c, which is still considered a linear equation. At that point, it would be a linear equation in one variable. But what makes an equation linear is there are no products of variables. So no x times y, no x times x, meaning no x squared, no powers in general. So you don't have any variables multiplied by each other, and there are no powers except the first power. That's what makes an equation linear. The following are examples of linear equations in two variables, and I've got 6 equations here, only one of which is straight out of the right form, if you will. Remember, when I say the right form, I mean ax plus by is equal to c, or whatever the variables are. And the only one that looks like that on this page is the first one. In this one, let's see. Sorry, I got slightly distracted there for a second. We have a is equal to 3, b is equal to -4, and c is equal to 7. Now, it's not necessary to identify a, b, and c. I'm just saying that if a was 3, b was -4, and c was 7, then our equation would look like that. The second equation, however, is not in the quote-unquote form in the definition, the ax plus by is equal to c, but we can make it look like that with just a little bit of manipulation. We could subtract 3x from both sides, which would cancel the 3x's on the right. And on the left, we have unlike terms, so all we can do is write them next to each other. -3x plus y equals 4. And because I can manipulate the equation to have the form ax plus by equals c, that means that the original equation is a linear equation. I don't have to actually do these things to call it a linear equation. It was a linear equation from this point forward, but because I'm able to make it look like the correct form, that's what constitutes it being a linear equation. You don't actually have to physically make it look in the form ax plus by equals c. And by the way, that form, and I should go ahead and tell you this right now, is called standard form. And I hate that name. I'm about to type standard form next to this. I hate the name standard form because the adjective standard is so non-descriptive. This is standard form. There are other forms with more descriptive names based on what the equations contain or what the equations are built upon. But if you ever see standard form of a linear equation in two variables, they usually mean ax plus by equals c. And even that's not consistent across mathematics. Some folks will say that it actually looks like this: ax plus by plus c is equal to 0. In other words, everything is on the left and 0 is on the right. Sorry, a notification pop there. Still had a notification pop up there. Just pretend that 0 is next to the equal sign. So even the name standard form is not consistent across mathematics. But in this particular book, in this homework, when they refer to standard form of a linear equation, they mean some x's with some y's equal to some number. Well, let's get back to verifying that all of these are actually linear equations. Now, for the rest of these, I'm not going to do as much algebraic manipulation. I am going to rewrite this one. In fact, I can just type this. I could rewrite this as negative 3x plus y is equal to 4, meaning that I can manipulate it into ax plus into standard form. And that means the original equation is equivalent to the one in red, which means the original equation is a linear equation. The next one's a little bit stealthier, but the dead giveaway is that none of the letters, none of the variables are being multiplied by other variables, and there are no powers. Well, the implied power is 1. So this is a linear equation, the one next to it, the one that says y minus 5 is equal to 1/2 x minus 14. Sorry, this red box was bothering me. But yeah, the third one is definitely a linear equation. It doesn't look like it yet, and I wanted that box to be red, not that that really matters. It's a linear equation because none of the variables are being multiplied by each other, and none of the variables have a power higher than 1. But if you wanted to verify it by converting it into standard form, well, first we would have to fix what is wrong with it. The first of which is there's parentheses. We'll just use the distributive property, and we'll get y minus 5 equals 1/2 x minus, and then 1/2 times 14 is 7. Still not in standard form, because for standard form, we would have to have all the letters on one side and all the constants on the other. Now, there is a misconception that the x and the y must be on the left side. Not necessarily. Equals is a reflexive relation, which means if you have an equation, you can just switch the order. So saying ax plus by is equal to c is the same as saying c is equal to ax plus by. It's almost like you're just standing on the other side of the screen and you're reading the equation from left to right, assuming you can read the letters backwards. So I'm going to get this current third equation into standard form by getting all the letters on the left, all the letters to the right and all the constants on the left. To get all the letters to the right, I would have to get rid of any letters that are currently on the left. So we'll subtract y from both sides. And then to get all the constants to the left, I have to get rid of any constants on the right, meaning I have to get rid of the minus 7 with the plus 7. And if I did that, then on the left side, the y's would cancel. Negative 5 plus 7 is 2. And on the right side, I would have 1/2 x minus y, and then the 7s would cancel. That's in standard form. Something x, something y equals something. But again, I don't have to actually do any of that to say you are a linear equation. The fact that I can is enough to make it a linear equation. I do want to go ahead and type what that equation was. It was 7 equals 1/2 x minus y. And because it's equivalent to standard form, excuse me, that's not what it was. How about this one? I think I said it right and typed it wrong. Let me just look at it real quick. Except it's not 7, it's 2. That's what I get for trying to do math in my head. Hold up. Got to do the math. -7 added makes a +2, 1/2 x minus y. Okay. God, wow, that was a train wreck. I'm glad I got it fixed. But the fact that the original equation is equivalent to the one in red means that it is a linear equation. Let's get through these other ones pretty quickly. The fourth one doesn't have x's and y's, but doesn't change anything. As long as I can get all the variables on the left, which I could do by subtracting 0.5t from both sides, get d minus 0.5t is equal to 4. Let's put some spaces in there. The fact that I can do that means that the original equation is a linear equation. Now, the last two are a little bit, for lack of a better word, degenerate. That's the actually the correct math word. If you ever see the word degenerate in a math problem, it means that your equation is missing a piece. For example, this equation is missing the y term. But that's okay, because back here, we said that any of the variables could be equal to 0. So if the number in front of the y was 0, then that term would vanish. So it's okay if it's missing a y. Now, is this in quote unquote standard form? Well, not really, because standard form basically says all variables on left, all constants on the right, or vice versa. We can make that happen by simply adding 5 to both sides. That would be standard form, which means x minus 5 equals 0 is a linear equation. And the last one, y equals 2, is technically already in standard form. If you really wanted to write it so that you could see the x's, you could say 0x plus 1y is equal to 2. The x's would disappear. The 1 in front of the y is understood. So this technically is in standard form already. This one wasn't, but by manipulating pieces around, it's equivalent to this equation. I don't think I like that. Whoa, come back. What happened? Okay, well, I didn't mean for that thing to disappear, so I'm just going to type it real quick. I believe it said 0x plus 1y is equal to 2. And we'll put this one back in standard form. 1x plus, yeah, and you don't have to put 1x plus 0y equals 5, but if you really wanted to force it to look like something x plus something y equals something, then that's how you can make that happen. Okay, let's talk about intercepts. I think all of you are familiar with the concept of an x-intercept and a y-intercept, but just to have the definitions out there, the x-intercept of the graph of a linear equation is the point where the graph crosses the x-axis. And to be honest with you, this is the definition for any equation, meaning that I could remove the word linear and it would be a more generic, all-encompassing definition. I'm trying to make my name disappear. I hate it when this happens. My name shows up, can't make it disappear for whatever reason. Hold on, folks. I know I can make this. Okay, I have no idea why my name won't vanish. Go away, name, you bother me. Okay, there it is. All right, but anyway, as I was saying, the definition of an x-intercept is actually not just for a linear equation, it's for any equation. But since we're talking linear, we'll leave it there. All right, so the x-intercept of the graph of the linear equation is the point where the graph crosses the x-axis. The y-intercept of the graph of the linear equation is the point where the graph crosses the y-axis. And I think we all kind of know this already. Well, I want to use the visual to motivate how to locate an x and y-intercept from an equation. So let's draw a line and let's just talk about the points where it would cross the x and the y-axis. Here's the x-intercept. Can you tell me anything about that points ordered pair? Well, based on where it's drawn in this case, you could say the x is positive, but that was just based on where I randomly dropped the line. However, if you're on the x-axis, your y coordinate must be 0 because you did not leave the x-axis, you did not move up or down. And similarly, if you're a y-intercept, then your y coordinate can be anything, but your x coordinate must be 0 because to stay on the y-axis, you cannot move left or right, which means your x has to equal to 0. So what does this tell us? What does this tell us? It tells us two things. Number one, define the x-intercept, let y equal 0 and solve for x. And vice versa, define the y-intercept, let x equal 0, and solve for y. And I want to repeat that this procedure, this process, if you will, for locating x and y intercepts is not specific to linear equations. It works for any equations. And there's my name again, and I don't really know how to make it disappear without randomly clicking on stuff and hoping for the best. So how about this? Nope, that didn't work. Anyway, to find one intercept, you let the other letter equal to 0. All right, so we are going to find the intercepts for the following equations graphs, starting with, okay, there it goes. Sorry, it just bothers me. All right, so starting with 2x plus 4y is equal to 12. So how do we find the intercepts? Well, you just alternate letting letters equal to 0. So let's start on the first equation with the y-intercept, x-intercept. It really doesn't matter which one you start with. You start by letting y equal 0. So what would this equation look like if we let y equal to 0? Well, it would be 2x plus 4 times 0 is equal to 12. And now just solve for x. If we solve for x, we get 2x. Well, first 4 times 0 is 0. But when you add 0 to something, it doesn't change anything. I'll see people subtract 0 from both sides of this equation. I think it's kind of funny. We get 2x equals 12. And if we divide both sides by 2, we get x equals to 6. And that means that our x-intercept is the pair 6, 0, because after all, an intercept is a point on a graph, and each point has an x and a y coordinate. We set off the x-intercept by letting y equal 0 and solving for x. This graph has an x-intercept of 6, 0. But what about the y-intercept? Well, for the y-intercept, we'd pretty much do the same thing. Let's make this one blue. Why? Why not? So for the y-intercept, you start by letting x equal 0. So if I let x equal 0 in the equation, I'll have 2 times 0 plus 4y is equal to 12. I can retap all this. It's kind of in the way right now. If we let x equal to 0, the equation becomes 2 times 0 plus 4y is equal to 12. But 2 times 0 is 0. And so the equation becomes 0 plus 4y is equal to 12. But 0 plus anything is itself. 0 plus 4y is 4y. You could also subtract 0 from both sides, but think about that. And now it says 4y is equal to 12, but if I just divide both sides by 3, I get y is equal to 3, which means the y-intercept is the point 0, because we started by saying x equals 0, 3. Now, that's technically how you find your intercepts. There is a faster way on some equations to do it. The faster way is to think, where's the 0 going to go and what's going to happen afterwards? For example, if we go back to the original equation before I did anything, come on. If we go back to the original equation, think about what would happen if you put in 0 for a letter, for a variable. For example, for the x-intercept, we put in y equals 0. But if I put in y equals 0, it's going to kill off the y term and leave us with 2x is equal to 12. I can look at that and say divide both sides by 2, and I'll get x equals 6. So it is possible in this equation to look at it and say for the x-intercept, the y term would disappear, and then I can solve 2x equals 12 to get x equals 6. And just like that, the x-intercept is 6, 0. Same thing for the y-intercept. For the y-intercept, you would put in 0 for x, but if you did that, it would kill off the x term, leaving you with 4y is equal to 12. I left the plus there because sometimes it's a minus, and if it is, you got to think of it as a negative. But I can solve 4y equals to 12 just by looking at it, divide by 4, and I get y equals 3. And so we get the y-intercept. So it is possible to find the intercepts by looking, thinking about where the 0 goes, and then solving what's left over after you put in the 0. But if you want to be cautious and thorough, I would work it out like you see here. Now, that being said, I'm going to need room, so let me pause the video and clean stuff up. All right, we got the beginning and the ending of calculating the intercepts. Now, could we do the same thing on B? Notice it's not in standard form, but that's okay. It's not going to change how we find the intercepts. Let's start with the x-intercept. And we do that. We start by letting y equal 0. Because remember, to be on the x-axis, you cannot move up or down, so your y-coordinate must be 0. If we put in 0 for the y, we'll get, and I'm going to draw this because it's going to involve fractions and stuff, and it's easier for me to draw them. If we let y equal 0, we get 0 equals 2/3 x minus 10. And then I can solve this in 2 or 3 moves depending upon your perspective of the fraction. Move number 1 is to add 10 to both sides to get 10 equals 2/3 x. Now, what you do next depends upon if you look at the 2/3 as a single entity, one fraction, or as 2 individual numbers, times 2 and divided by 3. What most people would rather do, and I don't blame them, is to get rid of the fraction. And I could have done it at the beginning by multiplying both sides of the equation by the denominator. That sets up 3 divided by 3, and they cancel. And then we get 30 is equal to 2x. And then we could divide both sides by 2 and get x equals 15. Now, if you can look at the equation, imagine the y is 0 and solve it mentally, more power to you. But when it comes time to getting points, it's better to write it down and see it because it's easier to catch mistakes that way. So when we let y equal 0, we get x equals 15, and that's our x-intercept. For the y-intercept, we let x equal to 0 and see what happens. Well, that's actually much easier to pull off because we put the 0 next to the fraction, and therefore the fraction dies a quick death. It's a fraction, it kind of deserves that. If we put in 0 for x, we get y equals 2/3 times 0 minus 10. But 2/3 times 0 is 0, and 0 minus 10 is negative 10. So when x equals 0, y equals negative 10. That means our y-intercept is 0, negative 10. So finding intercepts is fairly straightforward. To find the x-intercept, you let y equal 0 and solve for x. To find the x-intercept, you let y, that's what I just said. To find the x-intercept 0, you let, let's try this one more time. To find the x-intercept, you let y equal 0 and solve for x. To find the y-intercept, you let x equal 0 and solve for y. Or in general, to find one intercept, you let the other letter equal 0 and then solve. Now, the graph of a linear equation in 2 variables is a line. That's why the word linear was chosen to represent this type of an equation. And since we can draw a line with just 2 points, it is sufficient to locate the intercepts to draw a line, provided the line has both x and y intercepts, because some lines are lacking an intercept, as we'll see in a moment. So we're going to use the fact that intercepts are easy to find, and it gives us 2 points most of the time to sketch the graph of a line. For example, use intercepts to sketch the graph of each linear equation. You may recognize these linear equations as the same ones that we just found the intercepts for. So we're not going to refine the intercepts. We've already found them. We're just going to take advantage of them. For the equation 2x plus 4y equals 12, the first one, the x-intercept was 6, 0, and the y-intercept was 0, 3. Armed with this information, we can draw a pretty quick, if not rough, sketch of this graph. We need to go over 6 on the x-axis, up 3 on the y-axis. So if I go over 6, 1, 2, 3, 4, 5, 6, put a point at 6, 0, go up 3, put a point at 0, 3. Then all I have to do is connect them with a line, and it will look something like this. There we go. Let's move that line over a little bit. There we go. And there would be the graph of 2x plus 4y is equal to 12. We can do the same thing with the other one. Now, notice that for the second equation, y equals 2/3 x minus 10, the intercepts coordinates that aren't 0 are both larger than the previous one. They're 15 and negative 10. They're 2-digit numbers. When you are sketching a graph, you have the freedom to scale your graph however you want. On the first one, it made sense to go in increments of 1 because I was only counting off to 6 and counting off to 3. But on B, the intercepts are at 15 on the x-axis and negative 10 on the y-axis. I think in this case, it would make sense to go in increments of 5. And I need to go further to the right than I do down. So I'm going to put 3 marks on the x-axis and put a 5 here to indicate that's the scale and then 2 marks going down on the y-axis, and again put a -5 there to indicate the scale, because the scale on the x-axis and the scale on the y-axis do not always have to be the same. Our x-intercept is 15, 0, which would be at the 3rd mark on the x-axis, on the positive x-axis, and the y-intercept is at 0, -10, which is the 2nd mark on the negative y-axis. And all we got to do now is connect the dots, and we have our line. Let's move it down a little bit. Excuse me. So using intercepts to sketch a graph of a linear equation is easy, provided A, you can find the x and the y-intercepts, and B, the graph has both x and y-intercepts. And I keep hinting that it's possible for a graph to not have one or the other. So before I go to the next slide, I want you to think, is it possible to draw a line that does not have an x-intercept? And is it possible to draw a line that does not have a y-intercept? And is it possible to draw a line that has neither? Well, the answers to those 3 questions are yes, yes, and no. It is possible to draw a line that has no x-intercept. How? Well, if I want a line to have no x-intercept, that means it cannot cross the x-axis. And if you have 2 lines that don't cross, that means they're parallel. A horizontal line would have no x-intercept, with the one exception of it actually being the x-axis, in which case the entire line is made up of nothing but x-intercepts. And how would you have a line that has no y-intercept? Well, if the line doesn't intersect the y-axis, then it has to be parallel to it. A horizontal line would have only an x-intercept and no y-intercepts, except the rare occasion where the horizontal line is the y-axis, in which case every point on it is technically a y-intercept. So not all linear equations have both the y-intercepts. Well, I just got finished saying that. Is there anything hiding under here? Oh, no, I remember what I meant to do. I meant to actually draw what we just said, that if you have a horizontal line, there's no x-intercept, and if you have a vertical line, there is no y-intercept, with the rare exception that the horizontal line is the x-axis or the vertical line is the y-axis. Now notice that each one does have an intercept. This horizontal line has a y-intercept and this vertical line has an x-intercept. Is it possible to draw a line that has no intercepts? No, because if it's a horizontal line, it will hit the y-axis. And if it's not horizontal, then it's got to be tilted enough to hit the x-axis at some point. In other words, you cannot draw a line that misses both the x and the y-axis. You can only draw a line that possibly misses one or the other. But if it's not a horizontal line and if it's not a vertical line, then it will hit both the x and the y-axis. It is worth mentioning that it's possible for a line to have a single point that serves as both the x and the y-intercepts if that line crosses through the origin. The origin is the only point common to both the x and the y-axis. All right, so, well, I kind of gave this away, but it's here, so we'll go ahead and talk about it. The graph of a linear equation of the form y equals k is a horizontal line with x-intercept 0, k. Didn't mean to let this cat out of the bag yet. I was going to do a discovery path into it, but let's just go ahead and say it because it's here. If your equation of the form y equals k, then it is a horizontal line. And if it's x equals k, k is a constant, then it's a vertical line. Why is that? Well, think about it. If I have well, let's start with the equation y equals k. What is this, for example, we'll say y equals 3. What does this equation require of the letter y? It says it has to equal 3. And what does it require of the letter x? Nothing. It doesn't care what x equals because it doesn't even mention the x. So this equation says, I don't care what x equals. X can be anything, but your y must equal 3. So where are all the points on the graph where y is equal to 3? Well, we're allowed to go over as far as we want, but then we have to go up 3 because the equation says y equals 3. So we can go to the 4, right? We can go to the right 4 and up 3. We can go to the right 1 and up 3. We can go to the right 2 and up 3. But no matter how far we go, whether it's positive or negative, the y must equal 3. So we can go left or right wherever we want, but then we have to go up 3. And all the points that are up 3 are on a horizontal line whose y-intercept is 0, 3. So the equation, the degenerate equation, y equals k, degenerate because it's missing an x, is a horizontal line. And similarly, for an equation of the form x equals k, for example, if we said x equals -2, then this equation says your x must equal -2. I do not care what your y is, but your x must be -2. So if I were to locate the points where x is equal to -2, the first thing I would have to do is go to the left 2, because it says x equals -2. But I can't go up or down any. Excuse me, I can. In fact, I can go up or down as much as I want because it says nothing about what the y has to be. So as long as I go over 2 to the left, then I can go up or down as far as I want. So I could go 2 to the left and up 1, or 2 to the left and up 3, or 2 to the left and up none, or 2 to the left and down 2. Doesn't really matter, but all those points would be on a vertical line with an x-intercept of -2, 0. Not the most vertical of lines I've drawn, but I think you see what I'm getting at here. So keep in mind that not all lines have both x and y intercepts. If the line is horizontal or vertical, then it's lacking in an intercept. Just remember, y equals a number must cross the y-axis at that number. So it has to be a horizontal line. And x equals a number must cross the x-axis at that number. So it must be a vertical line. And that's the end of this video.